Let's go over question number 961, n repeated element in size 2n array. Now the question says, in an array A of size 2n, there are n plus 1 unique elements. So we have n plus 1 number of unique elements. And exactly one of these elements is repeated n times. Return the element repeated n times. So what we want to do is you want to return the number that was repeated n times. Now it says that we have an array A, so these are our arrays, of size 2n. So it's 2n for all of them. And for all of our arrays, n is going to be, for the first one, this is going to be 2 because this has a size of 4, this has a size of 6, and this has a size of 8. So our n is 2 for the first one because 2 times 2 is 4, 3 for the second one because that's 6, and then 4 for the third one, that gives us 8. Now it says that we have unique elements, that's n plus 1. If you were to add 2 to 1, that would be 3, right? So that means that we're going to have 3 unique elements. And if you look in our array, we have 1, 2, and 3 unique elements. So it's 1, 2, and 3. If you were to look at our example 2, we should have 3 plus 1. So that's 4 unique elements. So we have 1, 2, 3, and 5. So 1, 2, 3, and 5. And finally, for our third example, we are going to have 1, 2, 3, 4, and 5. And that makes sense, right? Because 2 plus 1 is 3, 3 plus 1 is equal to 4, and 4 plus 1 is equal to 5. And as you can see, we have 5 unique elements, 4 here and 3 here. The question also says that exactly one of these elements is repeated n times. So this is a key to solving our solution. So what's our n? For the first one is 2. For the second one is 3. For the third example, it's 4. And if you look into our array, we have one element that's repeated 2 times, n times. This is our n, and that's 3. And if you look at our example 2, we have to have an element that's repeated 3 times, and that's 2. We have 1, 2, and 3. And same goes for our example 3. We should have one element that's repeated n times, which is 5. 1, 2, 3, 4. So it's repeated 4 times. So we have to look for the number that's repeated and just return that repeated element as our result. To solve this problem, what we want to do is we probably want to get some kind of object to store the count of the keys, right? And for the first one, we will have a key of 1, 2, and 3, and it would have a value of 1 for the first one, 1 for the second one, and 2 for the third one, because 3 has counts of 2 and everything else has 1. And we want to return this as our result. But there is one thing to keep in mind. Well, you should note that other elements are going to have a value of 1 because they're going to be all unique except for that one value. So think about how you can maybe minimize the number of operations. So instead of getting count of all the elements in our array, maybe we can stop when we notice that we have more than one value for one of the keys. So that's a way to optimize things. So optimize. You want to return early when number of the same key is greater than 1. So give it a go. Try to solve it yourself. It doesn't have to be best solution. What matters is that you try. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our first solution, and like I said before, our first solution isn't actually going to be the most optimal solution, but I think this illustrates the problem really well. So we will start with this one. And as you can see, our runtime and memory usage is actually really bad. So faster than 13%, less than 5%. Timing space-wise is not very good. But this solution is going to have a time complexity and space complexity of O of n. Now, the first thing I want to do is I want to create a variable, and I'm going to name it count and set this equal to an object. So here we're gonna store our key value pairs where key represents the elements in our array and value is going to represent the count of the elements. So 1 is going to have a value of 1, 2 is going to have a value of 1, and 3 is going to have a value of 2 because we have 2 3s. Next, I'm going to declare another variable and I'm going to call this max count. and set this equal to number and negative infinity. So for this variable, what we're going to do is we're just going to store the maximum count to this variable later. And next, I want to declare another variable and name it result, and just declare it over here. And obviously here, we're gonna store our result. And let's just actually return our result here, because that's what we need to do later. Okay, all right, that looks good. Now our first step is to get the count of all the elements in our array. So to do that, we're going to let's just use a for of loop. So const is going to be key of our array, and we check if count key does not exist in our object. What are we going to do? We're going to initialize it with a value of 0. And if it does exist, we are going to increment counts at key by 1 each time. So let's just console log our counts object, and you can see that we have our result. We have key of 1, and it only has 1 value in the array. Key of 2 only has 1 count. 3 has counts of 2, and that coincides with our input array. And rest is for input 2 and input 3. Okay, so we know that our counts looks good. It just simply gets the keys in the input array and counts all the numbers up. So this is all it's doing for now. Now what we need to do is we need to go through our counts object and be able to access the counts and the key. And we need to store our result in the result variable and maximum count in the maximum counts variable. So let's just make a for of loop again. So const, and I'm going to destructure my array. So I'm going to have a key, and I'm going to call it count because it's count of numbers. Of what I'm going to do is object dot entries and pass in my counts object. Okay, if this confuses you, what it does is, let me just console log to show you. So I console logged object entries dot count, and you can see that what it returns is an array, but in the array it has my key value pairs. So key is 1, and we had a value of 1, which is count. We had key of 2, and we had a value of 1. We had key of 3 and value of 2. So it's going to give us these arrays. And what we do here is we use array destructuring to represent key for the first one, count for the second one, key for the first one, count for the second one, and so on and so forth. So if you're not familiar with array destructuring or object entries, that's all it's doing. It's just putting all the values in our object into array of arrays, and we are using array destructuring to access those values. And the first one is going to be represented by key, second one represented by count. Now what we need to do is we need to get the maximum count of the number. So what we do is the current count greater than our max count? If it is a case that our current count is greater than our max count, we want to overwrite that max count with our current one, because we're looking for the number that happens or occurs the most. We overwrite that with count, and then we want to store our result, which is going to be represented by the key, and this should be count, not counts. And as you can see, we have our results. So for the first one, 3 occurred the most. For the second one, it was 2. And for our last one, 5 occurred the most. Now let's just go over our code just one more time. Here again, we're just simply getting all the count of the elements in our array, and we are storing it in our counts object. Next is the harder part of this solution. Object entries, passing in our counts object returns an array of arrays where we get our key value pairs, and we use array destructuring to get key for the first one and count for the second one. And then we use our if statement to check, well, is our current count greater than whatever we stored for our max count? And if it is, we're gonna overwrite our max count with the current count and store our key to the result variable. And when we're done iterating through the whole thing, we just return our result and we get our result. So for this one, again, time is O of n, space is O of n, but although time is O of n, we have 2 loops here, right? And that's a lot of work, and that's why we are getting such a slow runtime. So let's try to optimize our code little by little. Now let's go over our second solution. And while I was looking at this one, I thought maybe I can use something similar to counting sort. And if you don't know what counting sort is, what counting sort does is it counts all the frequencies of the numbers and it stores that frequency into the index of the element. So what I mean by that is, for the first input, we will have something like 0, 1, 1, and 2. So where did this come from? Well, we have one count or frequency of one of the number 1, right? So our 1 will be stored at index 1. That's what represents the number. And frequency will be stored as a value. So our index represents the number. The values in that index represents the count. And we have one count or frequency 1 of 2, right? So we would have 1 here at index 2 because our number is represented by the index itself. So 2 has a count of 1 and now 3 has a count of 2, right? So we go to index 3 and store 2 as our value. So that's what counting sort is. Now, if you notice, our space complexity is actually worse. It's O of n plus k. And where does O of k come from? Well, I'll actually explain this later when we code. I think that might be easier to see. Now for this solution, what I'm going to do is I'm going to create a variable named count. And this is obviously going to store our count of the numbers. But actually before that, I want to find the maximum value in my array. So I'm going to call it max value is equal to math.max square operator and pass all our elements. Okay, that looks good. And next, what I want to do is make an array. I'm going to use an array.from, give a length of max plus 1 and fill this up with zeros. Okay, and this should be max value. Okay, that looks good. So let's just console log our counts array. As you can see, we just initialize our counts array with zeros. That's all we did. And we have to add 1 because if we were to get rid of 1, we would have only 3 elements, but we need to account for index of 0. So that's the reason why we have to add 1. Now, what we need to do is we need to put our frequencies into the correct index. Let's just use for each for this one. For each current value, what we're going to do is at counts at index current value, because our current values are going to be represented by the current index, and we increment by 1 each time. So as you can see, we have frequency of 0 for the element 0, 1 for our element 1, 1 for our element 2, count of 2 for our 3s. So it looks good, right? So let me just delete that. And what we need to do now is we need to find the maximum count. And let's just call that max count. And for this one, we are going to use math.max again. And let's just spread all the elements from the count. And if I were to console log this, you should have 2, 3, and 4 because our maximum count for the first input is 3, which had a count of 2, count of 3 for the number 2 here, and count of 4 for number 5. Okay, that looks good. So now all we're going to do is we're just going to return counts.index of the max count. Okay, we did get our result, but let's just go over this. So what we did was, after finding our maximum count number, what we did is we went to our counts array and looked for that maximum count and returned the index of that number. And remember, I said that the index represents the number itself in a counting sort. So that's why this whole thing worked. Now, let's just go over why space complexity is O of n plus k. And let's just console log our counts just one more time. I'll console log it here. Well, if you look, for now, we don't have any big gaps in our number. So let's look at our input. Our input goes from 1 to 3 and 1 to 5 and 1 to 5 for our third one too. But what if it was the case that we had a number that's really huge in our array? So something like 20. And you can see that when we had an input of 20, we have our array, counts array, and it's all filled up with extra zeros that's really unnecessary. You can see that for these extra zeros that we actually didn't use, that represents the O of k space complexity, and that's where it comes from. So O of n is our number of inputs, and O of k is that extra space that we have to make for elements that's not in our array. Okay, that explains our space complexity. And let's just go over our code one last time. So first thing we did was find the maximum value. We use that so that we can create our counts array, and we add 1 to our length because we need to account for 0, and we initialize it with the number 0. Here we got the counts of all of our elements and stored it into our counts array. And remember that the values in the array represents the count, and the index represents the number. Next, we created a max count variable to get the maximum count of our element, and we use that element to find the index of that number. And this works because index of the counts array represents the element itself. So this is pretty much kind of how counting sort work. If you're interested in how counting sort work, make sure to watch the counting sort video that I made. I think it should be really helpful. So this is another interesting solution, but there is definitely a way we can optimize this. First of all, space is O of n plus k, which is really bad. And this is still O of n, but there is a little optimization that we can do to maybe do it quicker on average. Now let's go over our final solution, and this is going to have the best runtime. So 96% faster. And the logic is that if you remember from the problem, all the numbers are going to be unique except 1. So that means that in our counts object, everything is going to have a value or count of 1 except one number. And we can optimize this by saying, well, if the current element happened to be already in my counts object, well, I know that I can stop because that's going to increase my count to 2. And there is no reason to keep looping through the rest of the array, wasting our time, because no matter how many times we loop through the array, we already found the answer already, because again, all the elements are going to have a count of 1 except one number. So when we find that non-unique number, we just want to stop and return that number and just end the whole thing. So let's try implementing that solution. So first thing I'm going to do is I'm going to make a variable named counts and set this equal to an empty object. And I want to iterate through my array. So let's just use for of loop, and let's call it key of a, and our key are going to be the values, right? And I just called it key because it's going to be key value pairs in our object. Let's delete that. So I need to check if counts at key exist. I'll just want to stop and return that key. And this works because if the key already exists in my object, it means that it at least is going to have a value of 1. And if that's the case, we just want to return that key and just stop our loop. Next, I need to check if my key does not exist in my object. So if it doesn't, I want to initialize it with a value of 0. Next, I want to increment the value by 1. Okay, we do have our result, and this is probably the shortest code for all the 3 solutions that we had. But let's just console log our counts over here, and let's just look at our last one. So what happened was when our input was 5, so our key is 5. Well, does our key exist in our counts object? No, right? So this is false, and we hit this statement. Well, does it exist in our object? Well, no. So this evaluates true. Sets the key value pair to 5 and 0, and we increment our value by 1. So we have 5, 1. Next is 1. Well, does 1 exist in our counts object? No. So we initialize it with 0 and increment by 1. So we have 1 and 1 here. Next is 5. So 5 is a non-unique element. So we go to our loop, hit our first statement. Well, does the key 5 exist in our object? Well, it does, right? We have a value of 1 already, or count of 1 already. So what we do is we immediately return that key and just stop looping, because we know that there is no reason to keep looping, because no matter what we do, all the elements are going to have a value of 1 except the number 5. So we stop there and just return our key, and we are done. So this way we are able to find the duplicate without looping the whole thing. because we just stop when we find the duplicate immediately. So this does actually have a time complexity of O(n), because worst case, it might be the last two elements, like this one, that's going to be the non-unique element. But usually on average, it might be faster depending on the input that we are given. If you guys find this helpful, make sure you guys like and subscribe. Thanks.